Hello and welcome to lesson 8 of our chapter on logarithms. In this lesson, we're going to be looking at solving mostly logarithm equations, some exponential equations as kind of part of that process. And we will be looking through 5 different examples out of the 10 for our classwork. And you'll check back on our classwork section on Google Classroom to see the work done out for the rest of the 5 problems of our classwork. So let's jump into the description here. We're looking at each of these equations that we're solving. They're going to give us 2 options for the very first step of the solving process. We're going to pick which one is the right choice, solve the equation for x, and then basically check our answer back into the original equation to see if we did it right. And then we'll talk about why the one we didn't choose was the wrong choice. So for the first one we're going to try right now is number 2. So our equation is the natural log of x plus 3 is equal to 2. So the option we're going to choose is option 2. So that's because we have natural log, our base is e, so it's kind of like we have the log of base e of x plus 3 is equal to 2. So we'd be doing e squared equals to x plus 3, which is what option 2 is. So I would just need to do e squared minus 3 to find x. And if I do e squared second natural log, I'm squaring e minus 3 equals 4.389. And I don't want to round too much since I'm going to be checking my answer there. So if I should be able to do the natural log of 4.389 plus 3, and that should equal 2, as long as I don't round too much. So if I do the natural log of 4.389 plus 3, it equals almost 2. That's like 100,000th off because we rounded a little bit, and so that means that we did it correctly. So we can check our answer by doing the natural log of 4.389 plus 3, and that does equal approximately 2, so we did it right. So the reason we didn't choose option 1, so remember for logarithm properties, if you're in one logarithm, the two things have to be multiplication instead of addition. We can only split it up into addition if we're starting out with multiplication, which we didn't here. So option 1 wouldn't have been just non-productive, it would have been incorrect. Moving on to number 3. So number 3 is a similar problem, but now we just have a regular logarithm. We have log base 3 that we're starting off with, so that's going to require a little bit of extra work on our part to use that. So the first thing I would do is kind of use our arrows and do 3 to the 2 equals 2x plus 1. And that is actually exactly what option 2 is giving us. So we would just have to figure out 2x plus 1 equal 3 squared. Well, we know 3 squared is equal to 9. And that means that if I solve that for x, it means that x is going to be equal to 4 if I solve that for x. So that is our solution, x equals 4. So we got to check to see log base 3 of 2 times 4 plus 1 should equal 2. So we're going to see if that's true. So if we simplify what's on the inside there, that would be 9 and have it equal 2. Well, we know that 3 to the second power equals 9, so log base 3 of 9 does in fact equal 2. The reason why option 1 was an incorrect choice was that, well, we're doing 3 squared, that's part of it, but we're not then doing 3 to a power of what's inside. What's inside the input of your logarithm was the answer if you're in exponential form. So it should be like option 2 instead of looking like that. So that is why we didn't choose option 1. And that concludes problem number 3 of kind of our first level sort of problems. Now moving on to problem number 4 here, the top one on the back of our second page of our classwork. we are solving log base 5 of 2x minus 7, and then log base 5 of 3. So essentially, these things are equal to each other. So it would be like 5 to some power equals 2x minus 7. And then we'd have 5, oh no, sorry. So 5 to some power y equals 2x minus 7. And 5 to that exact same thing, because they're both equal to the same thing, 5 to that same thing would have to equal 3. So if that's true, we can get rid of the logarithms if it's the base the same on both sides, and just say that 2x minus 7 and 3 are equal to each other, which is option 1. So if I solve that for x by adding 7 to both sides and then dividing by 2, I get that 5 is our answer for x. So let's check our work. So the left side is log base 5 of 2 times 5 minus 7. It should equal log base 5 of 3. Well, both sides right there are log base 5 of 10, of 3, I mean. And that means that we have something equaling itself. That's certainly a true statement. So now if I looked at the option 2, that is wrong because, well, they're changing log base 5 of 3 into 5 cubed. Well, that's not true. And equal to 2x minus 7. So they're basically combining the two logarithms into one logarithm and then trying to convert them. But that's not how it works when they're in one equation with each other like that. You should be using option number 1 instead for sure. Moving on to question 7. So this is our 4th problem of our video here. Question 7 is a little bit more advanced because we're going to be using logarithm properties. So we have two logarithms on the left-hand side of this equation. They're both base 2, and they're being subtracted. So when you have two logs that are the same base, you can divide what is inside of their parentheses. And that is what is happening in option number 1. We took the two logarithms, put 2x on the top and x minus 2 on the bottom. So now we're going to use what we learned about in step 4, and we're going to basically say we can get rid of the two log base 2 parts, and then we have 2x over x minus 2 would be equal to 3. So I'm going to make that into a proportion. So that'd be like putting a 3 over 1 right there. And so what I would do from there would be to do 2x times 1 and do cross multiplying. 2x times 1, 3 times x and minus 2. So that would give me 3x minus 6. And then I'm just solving that for x. So subtract 3x from both sides, we get negative 1x equals negative 6. Well, that means that x is going to be equal to 6. So we found our answer. Now we're just going to put 6 back into our problem. So we're doing log base 2 of 2 times 6 minus log base 2 of 2 minus 2. Oh, no, 6 minus 2. Sorry. X is 6. So this should be a 6 right here. And that is supposed to be equal to the log base 2 of 3. So if we rewrite that with all our simplified stuff in it, we log base 2 of 12 minus log base 2 of 4 should be log base 2 of 3. We just need to apply our logarithm properties to put these two together into one logarithm. So that would be log base 2 of 12 over 4, which definitely equals log base 2 of 3. So I didn't choose option 2 in this case. When you are subtracting two logarithms that have the same base, you're supposed to divide what's inside of the inputs, like dividing 2x by x minus 2 like we did in option 1. But in option 2, we're dividing two whole logarithms, which is not how our logarithm properties are supposed to work. And that's why option 2 would be the wrong choice. Now to our last problem of our video is problem number 10, our very last problem on our classwork paper here. We have a little bit more advanced of a problem again. So looking at what we're starting with, we have log base a of x squared plus 1 plus 2 times log base a of 4 equals log base a of 40x. So in both options, log base a of 40x is the right side. So we're going to ignore the right side for now. If we look at the left side, well, we have two logarithms of the same base added together, and we also have a coefficient in front of it too. The first thing we would want to do is put the 2 on top of the 4, and then we'd be multiplying the two common base logarithms together. So as far as the steps go, we're going to kind of come back to step 1. We'll do it first. So the first thing I would do is leave the first one alone. And then this 2 is going to square the 4. So I'm going to have log base a of 16 instead. So now we would be doing these two inputs multiplied by each other. And that is what option 1 is telling us to do from there. So now that we have 16 times x squared plus 1, we basically have now 16 times, we have two, okay, so we have a logarithm on both sides. When you have log base a, and they're equal to each other, that means their inputs are equal. So I could say that 16 times x squared plus 1 would have to be equal to 40x. And if I multiply this out, 16x squared plus 16 is equal to 40. And so now if I have x squared, that means I have a quadratic equation to solve. So I have 16x squared minus 40x plus 16 is equal to 0. So a trick to make a problem like this quadratic equation easier is since 16, 40, and 16, they all have 8 in common. So I'm going to divide all of those pieces by 8, which basically would be dividing 0 by 8 as well. So I'm going to divide everything by 8 first. That means that I would have 2x squared minus 5x plus 2 would be equal to 0. So you could do quadratic formula here, which you might be more used to, but we're going to do a quick factoring review. So I'd be doing 2 times 2 is 4, and then negative 5 is in the middle. So I'm looking for two numbers to multiply to 4 and add up to negative 5. That will be negative 4 and negative 1. And then I can use my box method here. So I would have 2x squared and 2, and then negative 1x and 4x. So I'm just looking for what's in common in all my rows and columns. So I have a 2 in common, and then an x in common, and then a 2x in common. And you'll notice that x times something is negative 1x right there. So that has to be a negative 1. And that should give us an answer. Oh, this is supposed to be a negative 4. So negative 4x right there. And then that means this 2 has to be negative as well. And so our equation would factor into 2x minus 1 and x minus 2 equal to 0. So if I solve each of these two separate parentheses equal to 0, I would get 1/2 and 2 as my two answers. So now I just need to check to see if those two are answers that are going to work in my original equation. And so what that means I got to do is I'm just going to use option 1 here. So I need to look at log base a, and then I got 16 times 1/2 squared plus 1. that should be the same thing as log base A of 40 times 1/2. So I just need to basically figure out on my calculator if 40 times 1/2 or 20 is going to be equal to what this is. So I'm going to check that now. So I can do 16 times 0.5 squared plus 1. Well, that equals 20, and that's what 40 times 1/2 is. So let's check our 2 as an answer. So we're going to do log base A, 16 times 2 squared plus 1 should be the same thing as log base A of 40 times 2. So this 16 times 2 squared plus 1 thing right here should be the same thing as 80, 40 times 2. So let's see if that's true. So we're going to do 16 times 2 squared plus 1. It equals 80, and we did it right. So our answer has been checked. And remember, you could do factoring to solve this. You could graph this equation to find your x-intercepts. That would be the solutions as well. Or you could do quadratic formula, all things you've learned about in prior classes. So remember, option 2 over here, well, the main thing they did wrong was that the 2 in the front here above the 4 should be squared, not 2 times 4 and get 8. So that 8 was the wrong thing in option 2. And the other 5 problems are ones you're going to try on your own, or check out my key that we posted on my Google Classroom page. And this completes our work with solving some exponential equations of various types with and without properties of logarithms involved, and kind of work through some different levels and even had some quadratics practice as well. And that concludes this lesson on solving exponential and logarithmic equations. Thank you for watching.